Okay, here we go. Lift off.
Humanity is going back to the moon as part of the Artemis II mission. And among the equipment carried by the crew is a wristwatch that looks relatively simple compared to everything else on board. All 4 crew members are wearing the Omega Speedmaster X-33 second generation. Inside a spacecraft like Orion, astronauts have access to highly advanced onboard computers, navigation systems, and digital interfaces. These systems handle trajectory calculations, timing for maneuvers, and communication with mission control. Despite that, astronauts still carry independent timing tools. A wristwatch provides a direct and continuously available way to track time without relying on the spacecraft's systems. It does not require accessing a screen, navigating menus, or depending on shared interfaces. It remains visible and usable at all times, which is useful during operations where attention is divided across multiple tasks. The Omega Speedmaster X-33 was developed with input from astronauts and space agencies to function in this type of environment. It combines analog hands with a digital display, allowing multiple time references and mission timers to be used simultaneously. The materials and construction are chosen to withstand the conditions of spaceflight, including vibration, temperature variation, and long-duration use. Its interface is designed to be straightforward to operate, including while wearing gloves. Physical buttons provide clear input without relying on touch sensitivity, which can be inconsistent in pressurized suits. The display is configured for readability in different lighting conditions, including low-light environments inside the spacecraft. Astronauts do not rely on a single system for critical tasks. Redundancy is a standard part of mission design. Having an independent timing device adds another layer of reliability, especially in situations where access to primary systems is limited or delayed. This becomes more relevant when considering the suit astronauts wear during launch and re-entry. The Orion spacecraft uses the Artemis Orion Crew Survival System, or OCSS, which is designed to protect the crew in case of cabin depressurization or other emergencies. The OCSS includes a pressurized garment that maintains a stable internal environment if the spacecraft cabin loses pressure. It integrates a life support interface that supplies oxygen and removes carbon dioxide. Thermal regulation systems help manage body temperature, which is important in both high and low temperature conditions. The suit also includes communication hardware built into the helmet, allowing continuous voice communication with the spacecraft and ground control. The visor provides both visibility and protection, while the gloves are designed to allow as much dexterity as possible under pressure. The boots are designed for stability and secure positioning within the spacecraft. Even with these design improvements, the suit still limits movement and makes interaction with equipment more deliberate. Fine motor tasks take more effort, and accessing complex interfaces can take longer. In that context, tools that require minimal interaction are easier to use. A wristwatch remains accessible without needing to reach for another device or adjust position significantly. It can be checked quickly without interrupting other tasks. The crew were also able to bring certain personal electronic devices into space, including their iPhones. These devices can be used for reference materials, personal use and entertainment, and certain operational support functions. Smartphones provide a wide range of capabilities, including data access, communication tools, and software applications. However, they still require handling, activation, and interaction through a touchscreen interface. They also depend on battery power and may not always be immediately accessible during specific phases of the mission. A wristwatch remains continuously available and does not require additional steps to use. It provides time information directly, without depending on other systems or interfaces. The continued use of wristwatches alongside advanced digital systems reflects how mission equipment is selected. Tools are included based on reliability, accessibility, and usefulness under real operating conditions. As spacecraft systems have become more advanced, the need for simple and dependable tools has not disappeared. Instead, those tools continue to be used alongside newer technology where they provide practical advantages. The Omega Speedmaster X33 is one example of that approach. It is not the primary system for timekeeping on the mission, but it serves as a reliable, independent reference that astronauts can use at any time. This reflects a broader pattern in spaceflight. Equipment is not replaced simply because newer technology exists. It is evaluated based on performance in the specific environment where it will be used. Wristwatches continue to meet that requirement. This is what Watch and Wardrobe focuses on. Rather than treating watches as accessories, the focus is on how they function in specific environments and why they are still used. Looking at watches in this way connects them to real-world applications, design decisions, and human factors. In environments like space, those factors become more visible because every piece of equipment has a clear purpose. Understanding why a wristwatch is still used on a mission like Artemis II provides a clearer view of how tools are selected and used in extreme conditions. This is Watch and Wardrobe. Thank you for watching.